how to pull a Revit model and export that into Rhino so you can analyze that using the DIVA plugin. And as you can see here, I just wanted to show you the kind of final results that we're looking for. We have our 3D model of this residential home right here, and eventually we'll get it to the point where we can add the clipping plane and be able to analyze this grid of sensors, which will perform a point-in-time illumination simulation. And you can see the highlighted results in color there in this 3D view, and then it's also ideal to take a top image of this so we can save this eventually as a PDF. And as you can see here, we'll eventually take this DIVA output and convert it into a PDF file. So I'm going to go ahead and start from the beginning here, and there's one file that we will need to convert the Revit window geometry into single 2D planes for the DIVA software program to be able to calculate the daylight passing through the windows here into our building. And so that script can actually be found on the server. So if you go to Arc Server 2 under the classes folder, scroll down to Arc 332 Spring 2017, DIVA for Rhino, Daylight Simulation Tutorial. And it is the cleanup window surfaces. We're going to use the top one here. So I'm going to go ahead and right click, copy that, and I'm going to paste that into another file location that I'm going to be able to find easily later. So once I paste this script file, I'll be able to access that relatively easy later. So I'm going to go ahead and close out all of this and go right into a Revit project. So you can use your own project to analyze it, or you can follow along with the Revit sample projects that they offer you. So I'm going to actually open up a project. And you can find the saved templates under My Computer, under C, Program Files, and it's Autodesk, Revit 2017. Scroll down a little bit and you'll find your sample files, and I'm going to use this RAC basic sample project, which is a residential home here. So I'm going to open that up and prepare it to be exported as a DWG file. So after you loaded up your basic sample project here in Revit, you'll need to go to the 3D view by going to the project browser on the left here. Scroll down to 3D views, double click on that. And from this view, this is where you'll be able to export all your 3D geometries into one DWG file, which you can then pull into Rhino, and it will save all of your set layers as well. And as you see here, the sample project has a lot of other kind of detailed items to this with the topography and vegetation. We're going to go ahead and remove as much as we can, so we're just left with the floors, walls, roofs, ceilings, and windows, so the DIVA simulation program can run a bit faster, not get bogged down by all the geometries. So with the visibility dialog box here, I'm going to actually highlight all of them, uncheck them, and then have none of them selected, so then I can quickly go through here and just choose the ones that I want to display. So casework, ceilings, columns, curtain panels, curtain systems, curtain wall mullions. I want doors. Keep going down. Floors. You can exclude the furniture because again, that will just kind of bog down the simulation program. Ramps, if there are any, roofs, stairs, and then walls and windows are all really important. So let's go ahead, select all those, look at our building, make sure everything that we really need is there. I think it looks pretty good. And since we're just going to be analyzing the interior of the space here, I'm going to go ahead and actually hide this back end here, these floors and walls that I don't necessarily need. Hide those elements. There we go. So anything that's hidden in this view will not be exported into Rhino. So to export, go up to the top left, go to the drop-down menu here to export, then CAD formats, DWG, and then with this settings tab right here, I'm going to open up this setup menu so I can change a few layers in here that are really important that'll help us down the road in Rhino. So looking at all of these Revit layers and then what their assigned names are going to be, I'm actually going to scroll down really carefully to the windows. And why I'm doing this is because the A glaze will be all of your window frames, but we want to actually isolate just the A glass. So it already automatically created this name for me, but it should be A glaze traditionally, and then we want to separate this from the frame. So I'm actually going to change the name here to A glaze W. Once we change that name there, we'll be able to isolate that and run the script. So once that's changed, I'm going to go over to my solids, and I'm actually going to want to do the polymesh solids. It kind of converts the 3D geometry a little bit in Rhino, but I found it to be a little bit easier on the DIVA simulation programs. You're going to see why here in a little bit. So, and then last thing to check is your units and coordinates. Make sure you're working in inches or feet. Not too important. So we'll go to next here, and then save this sample Revit file where you can find it. Okay, so once that DWG file was exported, I'm going to actually open up a new Rhino file here, the 64-bit, with my DIVA icons here. So I'm going to go ahead and file import that DWG. Okay, so alright, so to find that imported DWG, I realized I did not save as in my Revit program, so I actually have to go back to that sample project file under the C drive, program files, Autodesk, Revit 2017, and I accidentally saved it under the samples folder here. So now that I found my DWG, this is what I'm going to want to import here, and then you'll be able to see all of the 3D geometry in the perspective view. And so with this options, import options, for the most part it should be ready to go. I wanted to change my model units to inches because that's what I was working with in Revit. Can leave it automatic, and then these three checkboxes, if they're checked already, you can uncheck them. Don't necessarily need those to come in. So that should be good to go. You click OK, and now my 3D geometry will come in here, and if I right click on the perspective and go to ghosted, I can kind of see the geometry a little more clearly. Okay. So once I have all of this in Rhino here, I'm going to go ahead and isolate all the glazing components so I can run the Rhino script to change the 3D kind of rectangular boxes that Revit creates for Windows and change those into 2D planes. So if I go to my Layers tab on the right here, I'm going to remove the 5 pre-created layers from Rhino here. I don't need these. I can actually go ahead and select all my layers, turn off the visibility there, and then just turn on the A glaze and A glaze W. And so right now these are all individual block instances, which I need to kind of explode because they're kind of nested together in their Revit families. So selecting them all, I can type in the explode command, and now they should be separated into meshes, so I can go ahead and actually uncheck the A glaze and just be left with our rectilinear boxes, those window panes there. I'm going to do the same thing for the A glaze curtain panels here. They're already separated themselves, but again they come in as block references, so I need to go ahead, select all those, and explode those. And then finally, in the door, there will be an A door layer here that all your doors come in as. And if you actually look at your Revit model, there are a few glass exterior doors here that we actually want to convert into glass, so we can run the script on those too. So in Rhino, if you create a new A door W layer, I'm going to go ahead, select all them, explode them again. I'm going to grab all of them and just for now put them all on the A door layer. And then I can go here and select those 5 exterior doors here. Just holding the shift and select button here, I can add all of those geometries together, and then I can change the layer that they are on to the A door W. So we have another kind of window layer there. And again, I can turn off the A door now and just leave my exterior doors. So with those, I'm going to turn on the A glaze curtain panels again and the A glaze W again. So I'm left with all of my glazing components right here. And so we're going to go ahead and load that script that we previously copied. Typing in the load script command. This is a previous one that I used. I'm just going to remove that for now, but I'm going to go to add, and I'm going to go to my sample tutorial where I have the cleanup window surfaces Rhino script. Open that up, select that, and load that. It'll ask you if your glazing units that are imported as blocks, they first need to be exploded manually, and we already did that, so it's ready to go, yes. And then the command says select all your window meshes, so go ahead and select all those and click enter. So if you zoom in here, you can see that all your windows now come in as 2D planes. Okay, one additional step we'll need to perform after running that script. You'll see that these window panels are coming in 2 different directions. One's taking the outside surface, one's taking the inside surface. And so if you select one of these surfaces and type in DIR and enter, you'll see which direction these 2D planes are facing, and we actually want them to all be facing inwards like this. So we actually have to go and quick select all these brighter colored surfaces here and flip that direction of those surfaces. I'll do my best to kind of maneuver around the project here, selecting all of those surfaces that are kind of a brighter color. Now that I have them all selected, I can do that same dir command, and you'll see that they're all facing out. And so to flip that direction, you'll just use the flip all command up there. So type in an F and enter, and we can go ahead and flip all those and have those ready to go. So that will appropriately have the light kind of transmitted through those glazing panels. So once all those are fixed, we're going to go ahead and turn all the geometry back on. And before I forget, I'm going to go ahead and save this new Rhino file to a folder that I'm going to be able to find. Okay. Now we're going to add the ground plane. So I'm going to go ahead and create a new layer. I'm going to write A ground. And in that layer, select that. I'm going to go to my top view and create a surface. I'm just going to do the corner to corner rectangle here and just do your best to kind of capture a decent amount of the site there as a 2D surface. And you can go to a perspective and view that again with that DRI command, making sure that it is facing up. That's the appropriate way to have the ground reflectance. And it's a little bit too close to the first floor. It's actually overlapping that first floor geometry. So I can go ahead and go to my front view, and I like to turn off my O-snap setting here so I don't get linked to another geometry. Type in the move command, and I can actually shift the ground plane down a couple feet here so it doesn't interfere with the rest of the geometry. Okay. So now we have our ground plane in. We're going to go ahead and start the DIVA setup. So with the location tab here, I'm going to click on that and assign an appropriate weather file. And for our Bozeman projects, we need to find a city that has the relatively same latitude north. So Bozeman's about 45 degrees north, and once the options come up here, okay. So I'm actually going to choose the Minneapolis-St. Paul EPW file because that also has about a 45 degree north latitude, so give me roughly the same kind of solar angles throughout the time of day and time of year. Now we're going to want to add some nodes to our project, and this is a little tricky because originally you should be able to just select any of these surfaces and add the nodes to them, but these actually come in as poly meshes, which unfortunately we're going to have to quick draw in a new node floor. So kind of same thing with the ground. I'm going to add a new layer, and I'm going to type in let's do node floor. There we go. So in that layer here, I'm going to go to my top view. I'm going to zoom in. I kind of already have a good feeling for where everything is in this project. So if I turn off the visibility here, just go back to that node floor and just turn on the floor and the casework. And let's turn on the exterior walls here too. So in here, I can see the kind of lower level here, which is the living room kitchen area that I want to add the node floor to. So if I go ahead and actually create a polyline, and then with the persistent close, I can type in the P command, enter that, so it'll be a closed polyline here. So I'm going to start up and try to highlight this kitchen area the best I can. I know it goes right to the casework, and I don't want to go through the casework, so I'm actually going to draw this polyline around it. Just roughly try to draw this in best I can, and then stop it right here. Click enter. So once I create that polyline, I can actually select that curve, and using this option over here, I can turn that curve into a surface. So I'm going to go ahead and do that, and it still highlights that curve I had before, but I'm going to go ahead and just delete that right away. So I'm just left with this surface. And that is really helpful to be able to select that, make sure that is right at that first floor height there in the living kitchen space. And then I can go ahead and add my nodes to that. So selecting the nodes tab here, give that a second. So it's going to ask me to pick one or more planar surfaces, and so it's easiest to see this in the top view. Select that, click enter. Now enter the distance. You want the nodes to be present off of the floor, and if I remember correctly, this surface actually comes in with the upside down direction. So I'm actually going to click cancel this, select that surface again, and you type in the DRI command, and exactly, you see that it's facing down. The nodes will actually be placed below that floor surface. So if we do that same F flip command, there we go, and enter, now the surface will be upright. Let me try that again real quick. So nodes, select that surface again, enter, distance off of the floor, and since down here you can see that in Rhino we're working in feet, I want it to be about 2.5 feet off the floor, which represents that kind of 30 inches that typical work plane height. So 2.4, and let's kind of space these nodes, the distance between the nodes, kind of the same 2.5 feet. So as you can see, you created this nice grid of nodes throughout the kitchen living space here, and it's not running into any of the geometry. So I'm going to actually go ahead and select that surface again, and I don't want that to interfere with the floor, so I'm going to type the hide command and get that kind of out of the way there for now. So nodes in place. I'm going to turn back all my geometry visibility. Working in the nodes layer there, let's set the materials. So if you go and assign your materials, I'm going to go through these quickly. These are kind of have a nice drop-down menu with some options. And so most of the surfaces I'll choose reflectances, and then for all the glazing I'll choose visual transmittance. Or W is glazing. A glaze is actually the frame of the windows, as we separated those. A glaze curtain, those are glazing components. Mullions are going to be that generic furniture. If you don't know what it is, the generic furniture works pretty well as a default. A glaze W, visual transmittance there. A ground is the outside ground. A roof. I'm going to use the generic ceiling for now because some models don't have ceilings modeled in them, so the underside of the roof is going to kind of act as the ceiling for now. A wall, generic wall. Node floor. It's not visible, but I'm going to still just select a reflectance for that. Cute casework. Furniture, foundation, and stairs. Okay, I'm going to submit all those materials. Have those ready to go. Save my file, just to be on the safe side. And I'm going to actually set a camera view inside of this living space so we can create a visualization and false color images to kind of analyze how the light's entering into the space, analyze the luminance and potential for glare. So the best way I found to kind of get close is just carefully zoom in to the kind of outside of your building here, and then I'm actually going to orbit carefully into the space here. Carefully zoom there, there we go. And it's a little tricky, but get it as close as you can. About head height here, typical person standing. Once I got that, I'm going to right click perspective, go to set view, name views, and there's a little save as button here. I'm going to change this to living kitchen. Okay, so I got that set here, and what I can actually do is right click, set camera, show camera, and what that does is I can actually see it from my other views here, so I can actually select the back of the camera there, and with the OSNAP off, and I'm going to turn off the ortho as well, I can start to drag this kind of wherever I want in the kitchen here if I don't like the spot I originally had it placed. So right about there looks good, and then the angle looks pretty good. I'm looking somewhat down. I can change that if I want to. I'm going to go back here, select on the living kitchen, go to properties, and in the lens length here, we'll change that to 20 to give it a little wider view there. So that looks pretty good. I'll have to actually go back, set view, name views, and again with that save as, I'm just going to actually overwrite this living kitchen file already so I can update that view. And it's good to go. And now we can go to our layers. We can go ahead and make sure everything is on and run our simulation. So I'm going to save that and then go to metrics. So your simulation options will kind of pull up, and if you remember before, you got the daylight images, visualizations. This setting you can go through to set your interior perspective views, and that rendering will come out. I'm not going to run this simulation, but you can kind of adjust your time of day there to get the appropriate views that you want. I'm actually going to go to the daylight grid-based ones. And similar to the daylight factor, we're going to calculate the point in time illuminance, so we can see at that work plane height what the illuminance, the light levels that are falling on that surface. And so we have the luminance checked, clear skies, what we want. The fall equinox on November 21st at 9 o'clock is good. And either in lux or foot candles, doesn't matter necessarily what the units are, but I'm going to change it to foot candles because that's what's typically used in the United States. And then the radiance parameters, I can adjust that to ambient amounts to 3 or 4 or higher to create a higher kind of quality of the light simulation. So all these default settings should be good to go, and you can go ahead and run the simulation. So once your simulation results are complete and you have your metrics dialog box up here, you can see that there was a minimum of 67 foot candles produced and a maximum of 3,333. I'm actually going to change this min to max scale here so you can actually kind of read the color scheme a little bit easier. So I'm going to drop that down to 0, kind of acting as the lowest foot candle value possible. And then I'm going to set this to about 400 instead. So 400, anything above 400 foot candles is really kind of some intolerable glare. So it'll be nice and bright and red. So you can see that anything above that is probably just direct sunlight entering into your space there, landing on those sensors. So this color scheme, we'll go ahead and label all my nodes, have that displayed in foot candles, and I can load those simulation results. Okay. And the final kind of thing I just want to show you is if you kind of pull this out, you can actually create a clipping plane that will kind of create a plan view for us so we can kind of see those simulation results a little bit easier. So if you type in the clipping plane, and then I'm going to turn my O snap on and just kind of carefully select the end there, and I'm going to highlight this kind of second floor balcony. Okay. As long as it's parallel with the top floor there, that should be good to go. And so you see the clipping plane created right here. If you actually highlight that, go to your properties menu here, and then in the clipping plane options here, you can tell it to create the the clipping plane at both the perspective view here and the top view. So when we go into here, you'll be able to see that. Let's do a couple things. Let's turn off this camera here, and then let's turn this into ghosted. And I'm still cutting through the first or the second floor there, so I'm gonna go to my front view here, select that clipping plane, and move that down just a little bit there. Okay, now it's cutting through about halfway through the first floor there. And zoom in through the top there. Get this space relatively in the view that I want, and everything's looking pretty good. You can see the bright red is all that kind of direct solar gain that's falling directly on the floor there, and then the rest of it kind of tapers off into the rest of the space there. But we're going to go ahead and print this. You can go to File, Print, and keep it as a letter there, and change this from portrait to landscape so it's in the majority of the space there. It typically comes in as vector output, but since I've done this before, I needed to change it to the raster output. And then I want it to either be the print color or display color. I'm going to leave it as the display color, and I'm in the top view in the viewport. Okay, that should be good to go to go to my destination, make sure that's at your Adobe PDF. Go ahead and print that. And in that same folder, you can find one that works for you. I'm going to actually go into my visualizations just so I can kind of remember where it is here. So Revit to DIVA, change that to living, kitchen, false color plan, and then set the 09 21st at 9 o'clock, so you remember which time of day that simulation was run. Go ahead and save that. Alright, so my PDF of the plan came up here. I can utilize that however I need to. And then, so I'm going to just show you one last thing. Close out of my PDF here. And zoom out of the project here, still in the top view, and you'll see that DIVA will actually create that kind of scale for you for how that false color illuminance was rendered into your project here. So again, you can go ahead and file print this page to kind of place that alongside this plan there, so it's easy to interpret. So thank you for watching, and enjoy.